So good morning. My name is Iqbal Khan. I'm a technology evangelist at Alachisoft. We are a San Francisco-based software company. And today I will talk about how you can scale .NET applications with distributed caching. How many people have heard about distributed caching before? Okay. Good. So if you have any questions, please feel free to ask me. If you prefer to ask questions in German, I don't unfortunately speak German. My colleague does, so maybe she can do the translation. But otherwise, English is also my second language, so don't worry. As I'm talking, if you have questions, let's have it a more interactive discussion so that we can take advantage of. Okay, so the first, let's get a few definitions out. Scalability. What is scalability? Scalability in our situation is when you having high application performance, really good speed, even when you have a lot of load on the application. So if you have an ASP.NET application, the performance that you see with only 5 users, if you can see the same performance with 5,000 or 50,000 or 500,000 users, then you have a scalable application. A lot of people, when you test your application initially without the load, your performance would be good, and you think everything is fine, and you deploy this, and then when your business does some special promotion, let's say you're an airline and you did some weekend special, and suddenly everybody logs into your website and things crash. That's where you have scalability problems. And linear scalability essentially means that you have an application deployment infrastructure where if you add more servers, you can get a fairly straight line increase in throughput of transaction. And again, when I say throughput, it's all transaction throughput. How many users, how many transactions you can have. So then which applications need scalability? The most common are the web apps, ASP.NET, or in case of Java, it's JSP. These could also be web services. So where you have millions of users that you want to handle. If the Internet of Things is becoming very hot. All of the IoT devices need to talk to some backend. These are usually through web services, but I just wanted to classify that as a special use case. Another big buzzword these days is big data, where you need to do big data processing across many servers. That's also scalability. And any other server apps, where you need to do a lot of activity. So these are the if these are the applications that you are working on or you're planning to work on, then you need to be aware of the scalability, how to achieve that. So let's first define the scalability problem. What is the problem? Well, the problem is, first of all, the good thing is the application tier, which is your web tier or your application tier. That scales very nicely. I mean, you just keep adding more servers, and you have a load balancer in front, and everything at the application level at least, there's no problem. Unless, of course, your code is so bad that it just you have an extra loop of do nothing for 100,000 times at every request, then of course there's an issue. But most people don't have that. So application tier is not the problem. It's the data storage, the relational databases, the mainframe, your legacy data, which is what most applications still use today. That is where the scalability bottleneck is. NoSQL movement started in response to that, basically. There's also some other benefits to NoSQL, but in the context of scalability, the main value that NoSQL proposes is that it is a scalable storage compared to the relational databases of the world. But the problem is that in majority of the cases, if you're working on a business application, you have to work with the database that your company has already adopted, which is relational database. There are a lot of other technical and non-technical reasons where you cannot abandon a relational database. And so you don't really have to. If the whole purpose is to achieve scalability, you can continue working with a relational database, but understand that that's where the bottleneck is. So the solution, of course, is a distributed cache, an in-memory cache. NCache is one example of that. That is our product. But my focus today is not NCache. It's mainly on this problem and solution. So a distributed cache, the benefit of that over a NoSQL database is that it can work with your relational database. So you don't have to abandon your relational database to be able to achieve scalability. So that's the real value in one sentence. That's the real value that a distributed cache provides you. And being in memory means it's super fast. The disk can never compete with memory. And as we're achieving more and more transaction load, we are seeing that the disk, the rotating disk, is a major problem. So everybody is trying to find alternatives. So there's the solid state drives which have an improvement over it, but that's still no match for memory. So for a high traffic, high transaction application, to achieve scalability is to go through the caching. So here's how a distributed cache is typically deployed in an organization. This is your data center, your production environment. So if I can just, there. So here's your application tier. You can add more and more servers. Here's your storage tier. If you put a caching tier in between, a distributed cache essentially is a NoSQL style storage, but it's a key value store, but it's all in memory. It's distributed across multiple servers, and there's a cluster that is formed by a distributed cache, and most of your requests either go through the cache, or even if you go straight to the database, you put things in the cache. So the next time before going to the database, you'll check the cache. If the cache has the data, you don't go to the database. Why? Because the database trip is very costly. It is slow, and it causes scalability bottlenecks. So typically about 80% of the time you will find data in the cache, and only 20% of the traffic will go to the database. Even that is mainly updates. There are some reads also, but most of the updates have to go to the database, because that is your master data store. And the nice thing about a distributed cache is that it builds a cluster. So it's a TCP-based cluster. In case of NCache, it's a TCP-based cluster, which pools the memory and the CPU of all the servers together into one logical resource. And because you can add more and more servers here, it can scale in the same fashion as the application tier. So now the cache, which is an in-memory store, is no longer the bottleneck. Okay. So what are some of the scalability numbers that you should expect over your database? So, for example, if you had a 2-server cluster, here are the numbers: 32,000 updates, 50,000 reads, and these are with some replication. And I'll talk about those details, because it's an in-memory store. So many times you don't want data to be kept only in one server. You want it to be in more than one location, because if any one server goes down, of course, memory is volatile. So with 2, it's 50,000. With 3, it's 72, 96, 120, 140. So it keeps on going. It's a linear line both ways, with some differences in the actual numbers. So what are the 3 common uses of a distributed cache? Now that we've understood that it improves scalability, how do you actually use it? Where do you use it? Number one is the application data caching, where you cache the data that was in your database right here. You cache it here so that you can reduce those trips to the database. So the main thing to remember is that in case of application data caching, this is data that is coming from your database. So the data exists in 2 places. It exists in the cache, it exists in the database. The database, of course, is your master. So all the updates have to go to the database. That's the one use case, a very, very common use case, and most of the time that's why you would use a distributed cache. But that's not all. If you have a web application, let's say ASP.NET, since BASTA is mainly a .NET show, so I'll talk about that, but this applies to also Java web applications. ASP.NET, if you have that application, you can, in addition to doing this, you can also do these things. So you can store your session state in the cache. You can keep your view state in the cache, and I'll talk about those. And you can keep the you can use the cache as an output cache provider, so the page output can be put in it. In this case, the data exists only in the cache, so there is no master database where the data exists. So this is permanent data. This is transient data. Transient means temporary. So you create it at runtime, you keep it in the cache for a brief period of time, and then afterwards you throw it away. So a session, for example, is only good as long as the user is logged in. The same thing happens with with the view state. It's good only as long as the user is logged in. So that's the second most common use case. The third most common use case is the runtime data sharing through events. Normally you would do this through a message queue, like MSMQ is one. But they have their limitations. They are designed for a more distributed, geographically distributed environment. But if everything is running within the same data center, a distributed cache provides you much faster event propagation mechanism, much more scalable than a message queue would. So you can use a pub/sub model to share data. There's also this continuous query feature that you can use where you can monitor any changes that are happening to the cache. Again, in this case, the data exists only in the cache. Actually, this might also exist in the database, but most of the time it is treated as a transient data. You're created at runtime. The purpose is to share it with another application, and you want to use the cache as the platform. Again, keep in mind, your applications are here, so this application wants to share data with these applications through the cache being a common platform for sharing the data. So that's the third common use case for that. Any questions so far? Okay, so let's talk about what each of these are in more detail. The first is application data caching. So here's a typical example of what an application data caching code looks like. Very simple. You have a load method. You want to load a customer. So before you go to the database, you check the cache. So there's a key, which is usually a string-based key, and the key usually contains some type information like customers is the class name, or customer maybe. Customer : customer ID is the primary key, and the actual value, which is what got passed. So this becomes your key. You check the cache. If the cache has that customer, then no need to go to the database, just return. So if not, then you go to the database, you load the customer up, and then you cache it. So the next time you come into this, you will find it in the cache. So that's the model where you are yourself going to the database, getting the data, putting it in the cache. This is different from what this picture kind of implies. This picture implies that you're going through the cache, which is what we call the read-through model, and I'll talk about that later on. But the most common is where the cache is on the side. A typical cache, like NCache, and I'm using NCache only as an example here, but a typical cache would have a very simple API. There's a time, you connect to the cache. Most caches are named, so you create your cache and it's a named cache, just like a database is named. So this is like your connection string. Then you get a cache handle back. You use that cache handle to fetch the data, update the data, or remove the data. And when you're done using the cache, let's say at the end of your application, you disconnect. So it's a cache.dispose. Similar to the database model where you obtain a connection, you keep it, and then at the end of the application, you let go. So very, very straightforward straightforward API. Of course, there's more to it than this, but this gives you a gist of that API. So now that you want to use this for application data caching, what are some of the things that you need to be aware of? Again, keep in mind the data exists in two places, the cache and the database. So the most important thing is to make sure that data is always fresh, or the cache is fresh. Cache is fresh means whatever is in the cache is the same version of data that is in the database. So you don't want to have a banking application where I only have $1,000 in my bank, but I can withdraw that 5 times, So the classic problem of not having the cache updated. So keeping the cache fresh is a very important aspect. And so there are different ways that you can do that. The most common is to use expirations. Whatever you put in the cache, you expire it. So for example, let me see if I can give you a small example of expiration here. I don't know if you can see this or not. So here's, can you see this code? Can you see it? Okay. So here's of course you don't want to do that, but you've got a customer object. You put your values in the customer object, and then you go ahead and you add it to the cache. And at the time of adding, you specify expiration. So you're saying use an absolute expiration of 10 minutes. So keep this in the cache only for 10 minutes. At the end of 10 minutes, it will be removed, no matter what. So this is an expiration. Now, why do you do expiration? The reason you do it is because you're making a guess. You're saying this data is coming from my database. So I think it's safe to keep it in the cache for 10 minutes. I don't think it's going to change in the database for this much time. Now, you need to make that guess differently for different type of data. So some data is what we call reference data, which are your lookup tables, your product catalog, whatever. So that you can keep for hours, maybe even days, maybe even weeks. So you specify. So when you actually come here, so you just specify a date time value in terms of when do you want that data to be expired. But most of the time you do want the data to expire. You don't want the data to stay in the cache permanently because there's a database. It might change, but you're still making a guess. In other cases where you have what we call transactional data, these are your customers, your accounts, the activities that are happening at runtime. You can probably cache it only for a few minutes. So 10 minutes or 5 minutes or 2 minutes is what you would typically cache it for, because you don't feel comfortable caching it longer than this because somebody else might change it in the database. And so the expiration is only a guess of how long this data is safe to keep in the cache. The sliding expiration is usually used for transient data. So let's say sessions or others, where you're saying really that keep it in the cache as long as the user needs it. So for example, here I'm going to do the same thing. I've just said do an update and change that so no longer absolute expiration. Turn that off, and now I want the sliding expirations of 20 minutes. So this is saying keep this data in the cache as long as user is either reading it or writing it. But when there's no activity for 20 minutes, remove it from the cache. So this is different than the application data. This, you are doing it for transient data. In case of application data, you want to use absolute expiration, because it doesn't matter if the user is using or not. You don't want to keep it in the cache for that much longer. But in case of transient, this is the only place. So the transient is more like a cleanup. When nobody's using it for this long, just clean it up from the cache. That way your application does not have to keep track of it. So that's the first most common way of keeping the cache fresh. But again, that's just a guesswork, which could be wrong. So in some cases, you may have a database where multiple applications are updating the database. And in this case, you don't know you can't really predict when the data might be changed in the database. A lot of the cases fall under this category. So you're saying I can't really make a guess. I'm going to specify expression, just to be safe. But in addition to that, I want to also make sure the cache itself monitors the database. And now the SQL dependency is a feature that comes from the ASP.NET Cache object. Has anybody used the ASP.NET Cache object in the past? Or which is now called system.runtime.caching. Okay. So that the SQL dependency is a SQL Server feature which allows you to create a data set on SQL by saying, let's say, select customer where customer ID is 1000. So this becomes a one-row data set. It could be a multi-row data set also. And then SQL Server will monitor that and will notify the client. And the client in this case is the cache, the caching tier. It will notify the client that this dependency that you had set, it has been triggered. So the cache can then do one or two things. It can say, okay, the corresponding data has changed in the database, so I can either remove it from the cache, which is the safe thing, remove it, so what will happen? Next time the application needs it, it will not find it in the cache, and guess what? It's gonna not find it in the cache, it's gonna load it again from the database. So it's a way to ensure. Or if you have the other option is to say the cache should automatically reload it. The reloading of the cache is dependent on another feature called read-through, which I'll talk about. So those are the two possibilities that you do. But here you're basically saying I can't really predict, so I'm not going to rely on expirations only. I want to have the cache monitored because my data is sensitive. I don't want old data. In some cases it's okay to have old data for a little bit, but in many cases it's not. And this synchronization feature works against SQL Server. There's an Oracle dependency. There's NCache has its own polling-based dependency also. So those are different ways that you can have the cache monitor the database. Any questions on this? One thing to keep in mind is that if your application is the only application updating the database, you probably don't need this. But it's only when you have other applications, or even when you have DBAs going to the script and modifying stuff, even that is another application. So that's when you would need it. A third, so the keeping the cache fresh has two meanings. One, whatever data is in the cache should be consistent with the database, right? Another is that my new data is being added to the database, and I want that data to be automatically added to the cache also. So how do I do that? So for that you can use CLR procedures, which are available in SQL Server and also Oracle on Windows, but definitely SQL. And then use database triggers. And when let's say a new customer was added to the database, added to the cache also. So the CLR procedure becomes a cache client. And it makes the cache API call. One thing to keep in mind though, if you use the CLR procedure, you want to make async calls to the cache. Why is that? Anybody can guess why do you not want to make synchronous call to the cache? It's just to wake you up. I know a bunch of yeah, exactly, because it could be part of your database transaction, and you don't want the transactions to be very prolonged, because if you're sitting here, the cache is on a separate box, so to go out of this box and make it could be a multi-server update, could be costly compared to the database transaction. So by making an async call, you will immediately get the control back, and the transaction will complete. And of course, that means that the cache has to support async methods. Otherwise, you would need to dedicate your own thread to do so, which is also possible, but it's not as clean as having the cache do it. So any questions on the need to synchronize the cache with the database? Any comments?
Yeah, how many dependencies can you have and still have it be performant?
Very good question. Very good question. So there's a cost to this, because for every SQL dependency that you create, SQL Server creates a data structure on the server end. It has to monitor, right? So it needs to create some table, something to monitor, okay, if this data set is modified, then I need to notify this client or these clients. So, what if your cache has 100 million items, which is very possible. We've got customers that do that, especially antivirus type of companies. They have lots of data. You definitely cannot have 100 million SQL dependencies. I can guarantee you that. The database is going to choke. So there's also a trade-off about what do you want to do here. So SQL dependency is good if you don't have hundreds of thousands of them. Thousands to tens of thousands is probably okay. It depends on your hardware and all other things, but as a rule of thumb, it has an overhead on the database. So what do you do when you have a lot of data? Any guess? We could use one of the options here. And it's only to wake you up. I know that.
Probably we have to go on scheduled process, stuff like this.
Yeah, so the scheduled process would be this, yes, that's the polling one.
Yeah.
Or the CLR procedure could be one. Again, if you think that the updates are very, very frequent, then polling is probably a better strategy. But if you want to, if you have a lot of data, but the updates are not as frequent, CLR procedures are probably the most efficient way to do it. Because there are no data structures being created now. Whenever the update happens, you make the call to the cache. So the database becomes the client of the cache. Again, because in this environment, you're talking about situations where you have extreme transaction loads. So every small thing that you could do wrong could essentially kill the whole purpose of using a cache. That's why you want to make sure that. Okay, moving on. So again, you can do that against the database and also against non-relational sources. You can use files as a flag between multiple applications, but more importantly, you could have custom dependency, which is your own code. So let's say you want to, and this code gets called at an interval, let's say 10, 15 seconds, and you can go out to your data source, which could be a web method call or something, and check whether something has changed. If so, then you can come back and tell the cache, well, this dependency, this data has changed, so please either remove it from the cache or reload a new copy. So those are some same things. So these three things make sure that the data is consistent with the database. The fourth one is a cache dependency feature. This is again something that came from ASP.NET Cache Object, where you can have one-to-one, one-to-many. The relational data is all about relationships. And let's say if you had a customer object and all of its orders. And in your application, you had the ability to delete a customer. Most people don't, but I'm just saying hypothetically. Well, if you delete a customer from the database, you'll of course also remove it from the cache. If you remove the customer from the cache, there's no point keeping all of the orders in the cache. So either your application has to do all of that bookkeeping, or you just specify this dependency at the time of adding data. Then whenever you remove or update the customer, all of the orders are automatically removed by the cache. Again, data integrity reasons. So that's a very, very useful feature to have. If you don't have these features, then you have to do all of this stuff. Keep in mind the fact that the data exists in both places. There are some sensitivities that you need to be aware of. So that's one of them. The second aspect, so now that we've made sure that data is fresh, what else do we want? If you have a relational database, you're used to searching the database. But a typical cache is a key value pair. You have a key and then a value, which is okay, but not great. You want to be able to search. You want to be able to get collections of data back, because that's what the application is usually designed to do. You don't know the keys. There's no way. Let's say that if I have an application which you click and say, show me all my German customers. I don't know the keys, but I do know that select customers where customer.country equals Germany is a search criteria that I could use. That's how I would search in the database. I don't remember all the primary keys. So why not do the same in the cache? So a good distributed cache should allow you to search. Very, very important. So for example, let me show you here again. For example here. So again, you have the cache handle. Where's the cache handle? Right there's the cache handle. And so you can say select product where product.name equals something. And then you can do a cache.search and it gives you back all the data that you want. You can do the same thing with link. So for example, if you were to see the same thing here, so you have an I queryable, so that's your products, then you can include this in a link search here. So again, in a .NET environment, more and more people are using link to do the searching, not only on the objects within the application, but also the database. So a good distributed cache would provide you an interface for link, and at the minimum, do the SQL searching. So that, again, by being able to search, makes the cache more friendly and more easy to use. Similarly, a cache is not within the application process only. So there may be a small subset of the cache here, which is called the client cache, and I'll talk about that. But most of the cache is on a separate server. So if you have to fetch 1,000 items and you know the keys for whatever, let's say that you did the search, give me all the customers based in Germany, and you didn't get all the objects back for whatever reason. So you got all the keys. Now you can go and make 1,000 calls to the cache and get each of them individually. Or you could, if you could do like a bulk get, that would really help, because then in one trip you can get back 1,000 items. That's what you would do with a database usually, is not go 1,000 times. So having that ability makes your application much more, it's much faster than do this. One thing to keep in mind, that all of the searching that you do in a distributed cache is usually done in parallel. So because the data is distributed across multiple servers, so you would issue the cache client would issue the same call to all of them, and then get the data back and do a union of them on the client end. So that way it's faster to get the data than to go through it each server at a time. Any questions on this searching?
What if some of the objects that I'm searching for are not yet in the cache, but on the database server, and I don't know which ones are in the cache and which ones aren't?
Again, very good question. So you don't want to search if you're not sure that the cache has your entire data set. So the only time you want to search the cache without knowing the entire data set is when you have the keys, when you're doing the bulk, or there are other ways. For example, there are features called groups, tags, name tags. So as you're adding data, instead of searching it based on country equals Germany, you just have a group called German customers. And then all the objects that you've added to the cache and associated them with that group, you can say, give me all the objects that belong to this group. Or the tag is the same as a group, it's just more flexible, it's just a free-form text. And a name tag is, again, is a key and value, so you can give attributes to plain text. So if you're caching just textual data, XML data, that instead of just objects, because in case of objects, you can index the attributes of the objects, which is what the indexing does here. But in case of free-form text, you can create your own indexes by having name tags. So when you have this data grouping, then yes, you can search this. And because you have added the data to the cache belongs to this. So you know that whatever is in the cache is my complete set at this time. But give me all the German customers, you should do it only when you know that you have already loaded all the customers or in the cache. Otherwise, you will get an incomplete result. So in which case, it's better to go to the database and do the search and then come back. And again, these are the things that you become sensitive because you have 2 copies of the data and because the cache is a subset of the database. The cache will not have the entire database. It doesn't make sense to have the cache contain the entire database. Some parts of the data will have the entire sets. Those are the lookup tables, the reference data, and even some transactional data. It might have the complete set. So wherever you know that the complete set exists, you can do this type of a search. Otherwise, use these. Any other questions?
So if I make a database query, I'm not really getting what the benefit if I do this in the cache. Right? Is it really faster or why I can make a query on the database?
So there are 2 reasons why you want to do this. First, the data that if you know the entire set is in the cache is faster. It's all in memory. It's a key value pair. But more importantly, cache is more scalable. Even if you were to get the same performance as the database, what about the load issue? If everybody issued all the queries to the database will choke. That's why you go to the cache, is you put more and more data in the cache, because the cache will never choke. You can add more servers. Let's say if you only had 2 servers and they started to choke, you just add a third one, and now you just added 50% more capacity. And then when 3 servers choke, you add a 4th one. You have 25% more capacity now, because again, as your load increases. So those are the 2 reasons why you'd want to search the cache. But again, you don't want to search the cache unless you have the entire data set in the cache, whatever that data set is. So as part of your application logic, you have to determine for which data you want to search. Okay.
So why not have a complete in-memory database instead of a regular database and a cache? Just put a complete database in memory. Shouldn't that be even better?
It would be, but it would not be scalable. So there's the speed and there's speed under load. The scalability only comes by having multiple servers. Otherwise, these databases are pretty good. I mean, these are not, they perform really well. But an in-memory database is not distributed. It's also SQL. It has the same limitations as SQL. The reason this is distributed is because it's a key value based. So by having key based, you can partition the keys any way you want. So an in-memory database would be faster, but would not be able to scale. It may not be faster. It will be as fast as the cache, but the cache scales. It will be faster than a regular database. Actually, the regular databases are also using a lot of caching in their own architecture. So within the server, they keep a lot of data in memory also, based on the commonly used pattern. So the performance aspect of it, you can also gain through this. The in-memory databases have their place. I'm not trying to discount them. They do have their place. But in a scalability scenario, the in-memory database does not fit in. It fits in when you have a really high performance, more of a real-time need, but the number of transactions are not that great. Any other questions?
Is there an equivalent of locking records in the cache?
Yes, definitely. Definitely. Do I have the locking part? No, I don't have it here. But yes, in case of NCache, especially, and I can't speak for all the caches, but in case of NCache, yes, you can lock the records. There's also an optimistic locking where you can have multiple versions of them can be read, but only the latest version can be updated. So yes, the locking gives you the like halfway to the transaction. It doesn't give you the rollback, but it gives you the ability to update multiple items as one activity. So what you do, let's say that there's a lock API. So you should lock and then you specify key. And you have these 10 keys that you want to update, or 10 items, and you want to update them as one transaction. So you first go and lock all 10 of them. If you have obtained the lock, then you know that nobody else will be able to touch them. Then you go and update them all, and then you unlock. And there's a way that you can fetch and lock and update and unlock also in case of NCache. So there are no extra calls that you make. But the reason rollback is not very important in a distributed cache in comparison to a relational database is because relational databases have these things called check constraints, referential integrity. So you can have legitimate data, but just because everything is working, but the data is violating some rules, so the database rejects it. So that's why you have rollback mechanism. In case of cache, it does not reject any data. The only time it rejects it is when something crashes or some failure happens, which is not a rollback anyway, because something just broke, right? So there's no real need for rollback unless you just need to be part of a larger transaction and the cache actually failed. That's why the locking is more important than the rollback. I don't know of any in-memory distributed cache that provides rollback as far as I know, but locking definitely. Good question. Any other questions?
So if the cache is distributed, does this mean, and you said it's a logical unity, does it mean that if I insert something into the cache, there's no guarantee that I will, when I get it, that it's there, because it might be on another cache server when I do the request?
So when I say it's pooled together, it means it's one logical. Then the cache is responsible to make sure if you update something from this server that update is available throughout the cluster. Whether it is replicated or not, that's a separate detail. And I'll go over some of the caching topologies that a cache typically has, especially NCache I'll talk about. But at the minimum, you should know that this cluster means that whatever, even if you're connected to this server and you update something here, this client connected to this sees the change immediately. Yeah. So whether that is through replication or that is just through the access, I'll talk about that. But yes, it has to be consistent. Otherwise, the cluster is meaningless. If the cluster is not coherent, it's not always correct. It's meaningless. Okay, read-through, write-through are basically your code. So you implement a read-through handler. I'll quickly show you a read-through handler. If I can find it. Backing source. Okay. So you, in case of NCache at least, you implement a read-through provider, and this is your code. Again, it has three methods. There's an init method, which is called only at the time of startup of the cache. There's a dispose method, which is called when you disconnect or when you stop the cache. And there's a load from source method, which gives you a key and then a cache item by reference. And then you're supposed to go to your data source, whatever that is, get that data. Let's say you've got load customer here. You put that in and you specify expiration or any of that, and then you pass that back. And then this gets put in the cache, and the client also gets it. So in the read-through model, the application is only talking to the cache. The application does not, at least for that data set. Again, you can have a combination. For some data, you can use read-through. For some, you can go straight to the database. So you'll go to the cache and say, give me this customer. And the cache says, I don't have it. So and because you've told the cache that if you don't have it, go and call the read-through handler. The cache has your read-through, which is your code, running at this layer. The cache calls your code goes to your data source, whatever that is, gets the data, gives it back to the cache. The cache puts it in its storage so that next time it'll have it. And then as part of that, you can specify in your read-through what the expiration should be and all of the other stuff. And then the cache then returns this data back to the client. What the read-through does, it simplifies the client. The client only does cache calls. It does not need to go to the database. It does not need to make database calls. Now, read-through is a very powerful mechanism. It's not used for everything, though. You might have complex, let's say you might have a search query against the database where you get a collection of data back and you want to cache it all separately. Then read-through is not the way to do it. Read-through is good when the entire operation is one cached item. So whatever you're doing. So usually it's against individual objects, whether those objects came from one table or multiple tables, it doesn't matter. But that's what the read-through looks like. It's just a very simple concept. And the same thing happens, I think, so there's also the write-through. Again, you implement an iWrite-through provider interface. There's an init call that gets called initially. This is called at the end, and then you do write to data source. And then it tells you what the operation should be, whether it should be an add, it should be an update, or it should be a remove. And then based on that, and there's a overload which can be called on a collection of those items. So the read-through and write-through is your code. Write behind is basically write-through done in an async fashion. So you don't want to wait for the database to be updated. So you are updating the cache. So you then cache.put or cache.whatever update, and you put the key and the object. And the cache is updated immediately because cache is pretty fast. But the database, of course, will take its time. So you don't want to wait for the database. So you say use the write behind. So that way it gets queued up, and then the database updates are done separately. Or the database connection fails, it gets queued up again. In case of even a write-through, a database update failed, and you want the update to be done to the database, it gets queued up. Write behind is essentially write-through in an async fashion. Now, with the read-through, you can now combine read-through with the expiration that we talked about. And so when an item expires, instead of removing it, the cache now has the option of reloading the new copy. So the cache always has that item. It just gets updated periodically whenever you think it needs to be refreshed. So it changes the whole concept of expiration from expiration to more of a refresh by having the read-through. Again, in a high transaction environment, this is very useful because, for example, if you we had this one e-commerce customer, and they had a product catalog, and they had huge traffic. So they said if they didn't have this feature, when that item expired, it got removed from the cache, they would have tens of thousands of requests suddenly hit the database. Of course, the first one will go and put it in the cache, but by that time, tens of thousands of requests went to the database anyway. So to avoid that, they wanted to just never remove it from the cache, just update it always. So that's a use case. Any questions on read-through, write-through? Okay.
So how does the read-through prevent that when the expiration is hit, that that you have 10,000 of requests that all go to cache? Because do you lock it then?
So a read-through reload basically means you update that item at that point in time. So then it just becomes one of the update operations. So before that, people were reading the old copy. After that, they're going to read the new copy. But that copy is always, that item is always in the cache. It doesn't update, it doesn't remove anything from the cache.
how do so which of the requests triggers the request?
The expiration. So expiration is done as a back end activity. So expiration, there's a separate thread, at least in case of NCache, there's a separate thread on the server end that monitors which items need to be expired. So at the time of expiration, it says, okay, is there a reload option available? Yes. Okay, reload it. Don't remove it. Just reload it. So that item never leaves the cache. In case of if there is no read through, then it just removes it from the cache. Okay, runtime data sharing is again something that a lot of people don't really know that a distributed cache is very, very useful for this purpose. If you have multiple applications that need to share updates with each other, even within the same application, you're showing some data on your form, another client updates it, and you want it to be changed on your application, you can define a callback. It's a key-based callback, so you can say on update, notify me. If this item changes, notify me. And then you can get the new copy and you can refresh your page, for example. So that's one. Similarly, you could have, you could say anything that is added or updated or removed to the cache, notify me. So you could be monitoring the entire cache. Or you could have a continuous query. A continuous query is like a SQL dependency. So you specify a criteria. It says, okay, select, again, I'm going to use the same example. Select customers where customer.country is Germany. So I want this data set. So if any customer object with country equals Germany is either added, updated, or removed, the cache will notify me. So the CQ is a concept that is that's a very powerful concept in distributed caching. Also on the Java side, it's called in-memory data grids. They also have this concept where you are now suddenly able to monitor very sophisticated data sets. And of course, there's an overhead, as you said, to each data set. But because this is a distributed environment, the overhead is more scalable. I mean, it's more scalable than a SQL server being one server. But you can monitor. So there's a key-based, there's the entire cache, and there's based on a data set. And finally, these are the pub/sub events. So where one application, let's say you've added some data to the cache, and now you're ready to share it. So you say publish. So you fire a custom event. I've published this much data. And there are other applications or same instances of other applications that are looking for that event. So when they get that event, they say, okay, I have this much data, I can go and read it from the cache. So it coordinates data sharing. And again, very, very useful feature. I'm going to skip this. So you can cache the sessions. The view state. View state is something. If you're using MVC framework, there's no view state. But most applications have not moved to MVC yet. New ones are, but the old ones haven't. So in their case, a view state is essentially an encrypted string that gets sent to the browser. It just sits there until a postback is done, and then a browser sends this entire string back, and this could be hundreds of K in size. So this is a lot of data traveling from the web server to the browser and back. There are two problems with this. One, of course, performance, because your response time slows down. Your infrastructure is now heavily taxed because you're sending a lot more data. Second, there's also bandwidth cost. When you host your application in a data center, you're actually paying for how much bandwidth you're consuming on the internet. So this cost increases quite a bit. So by caching it, you just send this key. And all of this is cached on the server end. There's no need to send it to the browser if you can just cache it. So the next time a postback is done, this key comes back. There's a provider. In case of NCache, there's a provider, a view state provider that just kicks in and inserts this string back before the page gets it. So the view state is another one. And the same thing goes with output. I'm going to skip that. I want to actually go into the architecture of a distributed cache, which is something that will answer. I think we have another 15 minutes, right? Yes. More like 18 minutes. Okay. So what does a distributed cache look like architecturally? First of all, a distributed cache, a good distributed cache will ensure that it gives you high availability because it is running in your data center. It's like a database. You don't want your database to go down, so why do you want your cache to go down? Especially because you're using your cache not only for application data, where if you lost the data, you could still get it from the database, although there's a performance hit by getting it. But the transient data, you lose it, there's a cost. I mean, you just lost it. For example, if you lost sessions, all those users that were logged in would be very angry because they went through all those next pages, and right before they were about to submit process payment, suddenly they have to start all over again because one of your servers crashed. So you don't want to do that. So high availability is a very big aspect of this. So I'll talk about NCache as an example, but you can see this in other products, also see which ones do what. So NCache has, for example, a peer-to-peer architecture, and there's no master slave, there's no single point of failure, there's no majority rule. And because of that, you can add or remove any cache server at runtime without stopping the cache. Everybody is a peer, so if you drop any one, the cache continues to work. The cluster continues to work. So that's the first aspect of this. And that allows you to do this. The second is a connection failover support. That if any server goes down, any clients, and clients here are your applications, your server applications. Any clients connected to that server will not be affected. They'll continue to work with other servers. NCache has a built-in logic where the client portion of NCache knows that it can connect to other servers. It even knows what those servers are because it has the cluster membership information, which is propagated runtime. So the dynamic configuration, so it all needs to come together. So there's a dynamic configuration, there's peer-to-peer architecture, and there's connection failover. All of that combined gives you the flexibility that if any server goes down, you don't stop anything. Nothing stops. Everything continues to work. Very, very important aspect. Second is, so there are caching topologies. That should answer your question about synchronization. So in case of NCache, there are 4 caching topologies. Number 1 is called mirrored cache. It's typical active passive. There's an active and there's a passive. All the collants are connected to active, and whatever the update is backed up onto the passive. If the active one goes down, the passive becomes active automatically, and the clients connect to it automatically. Again, completely transparent, but it's a 2-node situation. It has limitations that you can't go more than 2 nodes. But you would pick this topology when you only have one dedicated node, and maybe you want to have, this could be your database or this could be one of the web servers. You just don't have the resources to have the servers that are needed. It's pretty fast topology, all the reads and writes are pretty fast because they're done asynchronous. All the replication is done async. The second topology is called replicated. In this topology, every server has an entire copy of the cache. So what does that mean? That means no matter how many servers you add, the storage capacity does not increase because you make that many more copies. But it has its benefits. So at some time you do want to make more copies for a lot of different use cases. And also every server is active. That means it has its own set of clients. And third, every client connects only to one server. So whichever server it connects to is either based on load balancer that you can configure or based on your own preference list. Whichever sequence you want. I want to connect to this one first. If that goes down, then I want to connect to this one, and so on and so forth. So this topology is good for reading. Updates are not as fast because they are synchronous. They have to be done synchronously because every server is active. That means let's say if you were trying to update item number 3, somebody else might be trying to update the same item here. Well, if you don't do it synchronously, you will update this, go back home thinking, oh, I'm done, and so will they. And now you have data integrity issues. So what happens is when you try to update item number 3, it gets a cluster-wide token. and it's a sequence number. So whichever sequence number you get, you will update stuff based on that. So on every server, you will get your turn based on that sequence. So even if somebody gets to that server first, they'll wait because they don't. I mean, their turn hasn't come yet because of that. So, but the updates are slow relatively, although they're pretty fast, but they're slow relatively because of the fact that they're synchronous, and you have to wait for them. So good topology for reading and for not very high transactions of updates. Benefits are that you can make multiple copies, and it has its own use cases. The third and the fourth topology are essentially variations of partitioning. And these are our most popular, in case of NCache, these are our most popular topologies. So partition cache and partition replica both are the same. There's partitioning, every cache, and this is where the scalability grows. But as you add more servers, the entire cache is broken up into partitions. The more servers you have, the more partitions you have. In case of partition replica, every partition has a replica on a different server. There's a distribution map, which is essentially like a bucket map. It gets created at runtime when the cache cluster is formed, and it gets propagated to the clients. Now, the distribution map does not change unless you add or remove servers, or somehow you readjust the buckets. So there's also a readjustment of the buckets when let's say one partition gets too much data because all the keys happen to fall into those buckets. So there's also a logic or a feature in NCache where it can rebalance those buckets. But unless buckets move, the distribution map doesn't change. But whenever it does change, a new one gets sent to the clients automatically. Everything is done all automatically. The partitioning gives you extreme scalability, and the replication gives you a combination of scalability and reliability. So any topology that does partitioning and replication together gives you that. There. So for example, if I had a 2-server partition replica and I wanted a third one, here's what would happen. So I have partition 1, partition 2. I just added a third one, so now partition 3 is created. So a new bucket map is created. Some of the buckets from here and here are moved to partition 3. And then replica 2, which was here, has to be moved here. And a new replica 3 has to be created here. All of that is going to be, in case of NCache, all of that is going to be done automatically at runtime. So that you don't have, so you just add another server, that's it. It's going to do everything for you. And this is true for both open source version and the commercial version of NCache. And a new distribution map is created and propagated to the clients when that happens. Any questions in this so far?
The replica data is then updated asynchronously in this scenario?
Both options are available. By default is async, which is faster, but which is what applies in most cases. But some cases you have very sensitive data, as I said, financial data. So you have, for example, Bank of America uses it for a corporate wire transfer application. So every cash item could be hundreds of thousands of dollars. They definitely don't want async replication, because of the fact that I could withdraw it multiple times, right? So in that case, then you have sync replication. The sync replication is basically you are updating item number 1. That operation will wait until item number 1 is updated here also. And if something fails, then you will be notified, of course. And then the application knows that this update failed. So both ways, yes. Any other questions?
Am I right in assuming that the distribution takes place within one data center, or can you also replicate across multiple data centers?
Okay, so the cache cluster is formed within one data center. But you can have another cache cluster in another data center, and then you can replicate across the WAN. Because 2 data centers are usually far apart, you don't want to build a cache cluster across them, unless they're really not that far. I mean, we have customers that have 5 or 10 kilometer distance, and the latency is like 1 millisecond or something, or less. So, but in most cases, when you have two data centers, you want to have two separate clusters, and then you want, in case of NCache, there's a WAN replication feature called bridge topology. So the bridge is itself a cluster, it's a queue. So whatever is updated here is queued up here, and then the bridge applies it here. Or in case of active-active, it's a two-way queue. But the bridge has now the logic where it says, okay, if this connection breaks, I will reestablish it, and I will continue to do my updates. In case of this, it does the same thing. Here, it does also conflict resolution. So yes, you can replicate across the WAN. And because this is async, the performance of here or here is not affected by the latency. So you could have, for example, one of our customers is Ryanair. It's a very popular airline here. And they have a data center in Frankfurt, in London, and Dublin. And they have NCache running in all three data centers. So when you have situations like that, you want to be able to make the cache consistent. One last thing. There's another feature called client cache. This is a very powerful feature. A client cache is actually a local cache that sits on your application server box. Just like any other local cache, except it's not. It's connected to the caching tier, and it's kept synchronized. In case of NCache, and actually some people also call it mirror cache, but we could call it client cache. So the client cache is a local cache. It can even be in proc. So this could be on your application, within your application process on your heap. And if it's in proc, then the data that is cached is kept in an object form instead of in a serialized form. In a caching tier, by default, the data is kept in a serialized form. But in an in-proc client cache, it's advantageous to keep it in an object form because you're fetching it over and over again, so you don't have to deserialize it every time, because serialization is a huge cost. That's one of the costs of using a distributed cache. In case of NCache, there's no code changes for using a client cache. You just program as if you're talking to the caching tier, and the client cache plugs in. And the client cache is good when you are doing more reads than writes. And so, for example, for ASP.NET Session State, don't use client cache. For View State, don't use client cache because you're doing the number of reads and writes are equal. But in case of application data caching, 99% of the time, the number of reads are much more than the number of writes. So use the client cache there. It's a cache on top of a cache. It reduces traffic to the caching tier, which reduces traffic to the database. So, and plus it's really close to your application, gives you huge performance boost. Any questions? Okay. I'm not going to go into the hands-on demo at this time, but any questions? So do you see, I hope I've convinced you that a distributed cache is something that you should consider using within your application. I'll quickly, NCache has been in the market for 10 years, so it's really popular. It's open source, Apache 2.0 license. There's also a commercial version of it. How many people know about Redis? Let's quickly go over that. NCache, I'll give you a brief overview of the comparison on what, for .NET applications especially, NCache versus Redis. Number one, NCache is .NET, Redis is not. Redis comes from a Unix background. By the way, Microsoft has ported Redis as an open source, the open technologies group. But ironically, they're not using that on Azure. They're using the Unix version. And when we did some testing in-house of the open source version, it's pretty unstable. But don't take my word on it. We usually don't say these things in writing. But the Linux version is definitely stable, but not Windows. NCache is purely .NET from top to bottom. Redis is not. NCache is also open source, so if you're only attracted to Redis because it's open source, so is NCache. If you don't have a project which is very sensitive and you're comfortable using open source, go ahead and use open source. It's free. It's on GitHub and also on our website. But if you have a sensitive project where you want support and you want some extra features, then go with the commercial. NCache has a lot of features. I'm not going to talk a lot about the performance and stuff, because that you can do your own benchmarking. But NCache is got the architecturally NCache gives you very strong high availability. Clearly, the caching topology we just went over. We have WAN replication, which they don't. We have GUI-based tools that they don't for admin and monitoring. We have security encryption that they don't. We allow you to search the cache, which they don't. We have data grouping in cache that they don't. We have read-through, write-through cache loader, they don't. They do have some form of a cache loader, something basic, I think. We have database synchronization that they don't. We have cache dependency. They do have ASP.NET session state. Microsoft gave them that. We have view state and a bunch of others. There's actually a full-blown comparison document. I hope I have internet here. So if you come to our website, you can go to the comparison and just come here and click on Redis versus NCache, and just go ahead and download the comparison. It'll give you a full-blown comparison of the two. And again, all the comparison that we do is based on published stuff, so we don't make up stuff. That's why we don't do any benchmarking comparisons, because those things you can very easily become subjective. So I would encourage you to come to our website, read about NCache, and go ahead and download the enterprise edition of NCache. That gives you all the features. If you're only interested in open source, go ahead and download open source. It's all free. It's also on GitHub. Any questions?
So, apart from this support, what else is missing from the open source version?
Go into edition comparison. So, in the caching topologies, so there's a complete comparison table. The open source version of NCache has more features than Redis. Let me just say it, just in a summary. And then, of course, the enterprise has a lot more. As I said, NCache is the oldest .NET cache. It's been in the market for 10 years. Very stable, very, very popular, and very feature-rich. I don't think anybody comes even close to NCache in terms of features. And here's the locking that we just talked about. I think you're the one who asked somebody here. Yeah. So, any other questions? Yeah.
From the table, I just saw that Azure and Amazon are only supported in the enterprise version. So what would you need to host the open source version of this?
Actually, that is not true. If you come and say NCache Azure, as of today, only the open source version is in the marketplace. So if you come to the Azure marketplace, we only have the open source version. What we are planning to do is to change this. We're going through that change. We're going to make the enterprise edition available in the marketplace. But open source is there. I mean, you can go and get a VM, install open source, and it's going to work. Open source works perfectly on Azure. Currently, it's in the marketplace. We're going to take it out of the marketplace and only keep the enterprise edition in the marketplace. But that doesn't mean that you cannot use open source. You just go and get a VM. Okay. One more thing. Actually, this is something that Azure Redis is only available as a service. That means you don't get to access the servers. You don't see the server. You just see the API. NCache does not take that approach. We want you to have full access to the server. We want you to run it on VMs so that you can monitor everything, you can configure anything. Because NCache has read through, write through a lot of server-side stuff that you can do if you have access to the servers. So even open source is all VM. We're about to release the cloud licensing for the enterprise edition. So the enterprise edition of NCache will also be on Azure and Amazon. You just go to the marketplace and you just, but it'll be all VM based. It's not going to be a service. We've intentionally not done the service because we want you to have a lot more control. And I think, when we talk to our customers, the feedback that we got is that they wanted control. They don't want just a black box. A black box might be okay for a less technical person, they don't have the resources, but serious players who are putting a lot of stake on this infrastructure because their application needs scalability, need control. So that's what it's going to be. Thank you very much. Appreciate your time. And please do go to our website and take a look at NCache. I encourage you. And if you have any questions, just contact us. And we'll be more than happy to give you a demo and answer your application-specific questions. Thank you.